All right, this is the second half of 10.2. Now we're going to be using the dot product between two vectors to find the angle between those two vectors, okay? So first, let's understand this concept of an angle between two vectors. Notice the picture over on the left here. I have vector u and vector v both sharing the same initial point. And you can see that when they do that, they create this angle theta. This is known to be the angle between those two vectors, okay? Now notice I've put a stipulation on the value for theta. We're saying that theta has to be between 0 and pi, or 0 and 180 degrees, okay? There's a couple reasons for that. So first, understand that while we have this angle that I've drawn theta between u and v right now, there's technically a second angle, which would be this guy, and that's clearly going to be more than 180 degrees, right? So we've put this designation on theta that it has to be between 0 and pi, or 0 and 180, to avoid ambiguity between which angle, the blue angle or the red angle, we're talking about, okay? I would say the other reason, too, you have to think about is, let's say I reposition vector v here. Let's say it's doing that. Now there's an angle, I would say this is 180 degrees, but then so is this, right? Once I rotate that beyond 180 degrees, let's say I now make it out to here, now we would want to express the angle in over here in this fashion, okay? So hopefully that gives you some insight into that restriction, all right? Now, how do we in fact find the angle between our two vectors, okay? You notice I have a formula here. Cosine of this angle theta is going to equal the dot product of the two vectors, okay? So I want you to understand this is a dot product right here. And then that's being divided by the product of their two magnitudes, okay? So this would actually be a scalar product, right? Because both the magnitudes are scalars themselves. All right, and in this video, we're just going to be looking at utilizing the formula, but understand if you want to have a better idea of where this formula comes from, it can be proven using the law of cosines. I think our textbook has a good explanation of that, or you can do a quick Google search, okay? So let's find the angle between the two vectors v and w here. So that's going to require 3 initial calculations for us, okay? So we'll have to begin with, let's do the magnitude of vector v first, which should just be equal to the square root of 2 squared, or 4, plus negative 4 squared, which is 16. So that's going to give me the square root of 20. You can simplify that radical, but there's really no need to, okay? Now I will find the magnitude of the second vector, which would be the square root of 3 squared, which is 9, plus square root of 6 squared, which is 36. Okay, and that's going to lead me to square root of 40. Okay. Next, I find the dot product between these two vectors. And recall, that's just finding the product between the horizontal components and adding that with the product of the vertical components. So that's 6 minus 24, or negative 18. Okay, now I'm ready to calculate the angle theta between these two vectors. So applying the formula from above, right, it was cosine of the angle theta is going to equal the dot product between these two vectors, which is negative 18, divided by the product of their magnitudes. Okay? And you're more than welcome. You can simplify that fraction if you like, but I personally just, I like punching this all into the calculator at once. To solve for theta, I'm going to need an inverse cosine. And I'm just going to input all this into my calculator at once. Okay, now be careful when you do that. Make sure, this is crucial, that you put parentheses around the radical 20 times radical 40 there. If you don't, then you'll violate the order of operations that this formula has set up, and you will obviously not get the right value. Okay? So I'm ending up with approximately 129.5 degrees. There we go. Okay, I would suggest you try to input it yourself so you can see if you wound up with the same number as me. All right. Okay, now moving forward, let's give you a quick concept of parallel vectors and orthogonal vectors. Okay, so parallel vectors are two vectors where there's a non-zero scalar alpha such that vector v is equal to that scalar of alpha times the vector of w. Okay. What makes these parallel vectors is that the angle between them would be 0 or pi, or 0 degrees and 180 degrees. So parallel vectors have to have an angle between them of 0 degrees or 180 degrees. Why do I have both as a possibility? We'll think, let's say here's my first vector, and then here's my second vector, sharing the same initial point. The angle between those two vectors would definitely be 0, and they're considered parallel to one another. Or you have this other possibility. Let's say this is my first vector, and then here's my second vector sharing the same initial point. The angle between those two would, of course, be pi or 180 degrees. Okay. Now, rather than calculating the angle between the two vectors to see if they're in fact parallel to one another, you could just use this property right here that's saying if you multiply one of the vectors by a scalar, that it should equal the other vector. Okay, so notice the example here that that shows this. I have vector v, 6i minus 2j, and vector w, 3i minus j. Notice that those are considered parallel to each other because if I just took vector v or vector w and multiplied it by a 2, a scalar of 2, it's going to result in vector v. So that's a quick, easy way that you can check whether they are in fact parallel to one another. All right. Next, we have the concept of orthogonal vectors. Orthogonal vectors are known as perpendicular vectors. Okay, and there's a property associated with these, and their dot product says for two vectors to be orthogonal, their dot product is going to have to equal 0. Okay. So what that's telling me is that if the angle between my two vectors is pi over 2 or 90 degrees, the vectors are orthogonal to each other and their dot product better be equal to 0. Okay. Notice in this example, vector v and vector w, if I find its dot product, that would be 4 times 2 added with -1 times 8, which of course is 8 plus -8 or 0. So the fact that that dot product is 0 proves that these are in fact orthogonal. Okay. All right, now you move on to practice 2. You're going to try to find the angle between the two vectors that are given there and make some observations about the results as they relate to the properties on this screen. Okay, pause the video as you work through them, and then you can come back to the video and check your work with mine.